Let's talk about beats, and I'm not talking about the food. I'm talking about the sound and the rhythm. So I have here a sound generator. This is the Lab Quest 2, and I'm going to play 1,000 hertz. Now I'm going to play 999 hertz. Now some of these with really fine-tuned hearing, especially the musicians out there, I would guess, can tell the difference between the two. But ordinarily, if I played one of those two notes, would you be able to tell which one it is? Probably not. You might not be able to tell if one's higher or lower than the other one. Now what happens if I play them at the exact same time? What's going to happen? Well, since they're not completely in sync, that means that the waves are going to, at some points, are going to be completely opposite. One's going to be peaking while the other one is dropping out. In other words, I have a point of great compression of air followed by overlapping with something with not much air, and so they'll tend to cancel each other out. And there'll be other places where they're both creating compression waves at the exact same time, and when you get the two compression waves, you get a louder sound. And so what should happen is you get these periods of loud sound and very low sound, points of great compression and great rarefaction. And so this is what happens when you play them both at the same time. Now, that sound, those are beats. Now, the frequency of those beats really depends upon the difference between those two. I did 1,000 hertz and 999 hertz, so the difference is 1 hertz. 1 hertz is the frequency. Flip it over for the period. 1 second is the reciprocal of 1. And so what you should hear is that it gets really loud every second. 1001, 1001, 1001, 1001. Now, if I change that instead of 999, let's get it even closer. So 999.5 hertz. And now the difference, so we're talking about, assuming that I can pick it up there, 1,000 hertz and 999.5, even though it says 999, it should be 0.5. Let's try the, nope, it's still just displaying 999. Let's see if it'll actually take it. And I can tell if it takes it or not based upon the frequency or the period of what shows up, because right now I have a half hertz difference. And if I have a half hertz difference, so the frequency is 1/2, the reciprocal is 2, so the period is 2 seconds. So it should get loud every 2 seconds. That's not quite what happened there. So the frequency, was still at 1 second instead of a half second. And so apparently this machine doesn't take half hertz. So let's go the other way. Let's go 998. So now my frequency is the difference between those two, between 1,000 and 998, which is 2 hertz. So I have a 2 there. If I take the reciprocal of 2, I get 1/2. And so now my period should be 1/2 of a second. And so it should, instead of that wah wah every second, it's now every half second. So it should be twice as fast. Now, the question is, what can I do with this? Well, I'm now going to play, I'm going to stick in here 10,000 hertz. And now I'm assuming that it'll be able to be picked up, and if it doesn't, actually, it might work better. I know 1,000 hertz can be heard. Let me unlink those. So I'm going to do 1,000, and I'm going to do 9,000. And so I've got these two different frequencies. These are really high pitched. Now I've lost some of my upper level hearing, and so I can barely hear it, but I know to hear it. I know when I hit the button, so I'm listening for it. Ordinarily, I don't hear these type things. Well, here's 1,000. Incredibly annoying. Here's 9,000. Now, if I play them together, my beat frequency, since it's 10,000, 9,000, the difference is 1,000. My beat frequency is 1,000 hertz, so it should sound similar to when I just did 1,000. So here it is when they play together. kind of whiny and tinty, but I'm going to play it one more time, then I'm going to stop it, and then I'm going to play 1,000 just to show the difference. It's definitely more audible to me. And then if we break this down and just do 1,000, it is the same frequency. One is a lot tinnier, but is basically the same note. One's louder, I should say. One's louder, but it is basically the same note. There's Audacity as a software it's free, that you can download, that really does the same type thing if you want to play around with it. I'd recommend it. Personally, I find it really neat. But it does answer one of the questions in Hewitt's book, where he talks about having these incredibly high frequency sounds and what would happen if you play these things that are inaudible to the human ear. What would happen? This is as close as I can come. I've actually tried to duplicate the Hewitt problem, but I can't find anything that will produce sounds like that. I've thought about going to a pet store and taking 2 dog whistles and blowing them simultaneously, but they probably discourage my sticking that stuff in my mouth, and also I'm not sure I want to, considering the other people like me who would have done this same experiment. Figuring that the dog whistle, the quality control is off just enough so that they will not be exactly the same frequency. But Hewitt has a problem where he talks about frequencies above the human hearing and what happens if you play them simultaneously, and he talks about the beat frequencies where it's something that the human ear would actually pick up. And so that's the closest I can get to demonstrating that what Hewitt said is true. So there.